Hey gang, this is going to be a quick slideshow on a couple of different things, even and odd functions and also symmetry. So hopefully you have some notes ready to go. First of all, a function is even. If you plug in a negative x, so f of negative x equals f of x. If you plug in a negative x and you get the original function back, the function is even. A function is odd if when you plug in a negative x, you wind up getting a negative of the function. So I'll give you a minute to write those two things down. The main thing is to remember that to determine even and odd, you're plugging in a negative x and then you're looking to see what happens. If you get the original function back, it's even. If you get the opposite function back, it's odd. Let me give you an example of what I mean. So here's an example question. We want to know whether this is an even or an odd function. So what I'm going to do is I'm going to plug in a negative z. So notice that everywhere there was a z, I replaced it with a negative z. And then when you take a negative z and you square it, it winds up becoming a positive z. And so notice that this function, these two functions, they're the same. Nothing changed. Therefore, this is an even function. Here's another example. Negative 4x to the fifth plus 3x. We're going to plug in a negative x everywhere. So when I do that, so when I plug in a negative x everywhere, so I plug in negative x here, and I plug in negative x here, notice that these two functions are not the same. Therefore, it's not an even function. However, these two functions are opposites of each other. Notice that this was a negative, now it's a positive. This was a positive, now it's a negative. So therefore, this is an odd function. So even functions, nothing changes. Odd functions, everything changes. And if you have a function where some things change and some things don't, well, that would be neither. That would be even or odd. It would be a neither function. All right, so that's all you really need to know about even and odd functions. Pretty straightforward. Now let's talk about symmetry. When we talk about symmetry, we're talking about how the graph looks. And there's three different types of symmetry. There's x-axis symmetry, there's y-axis symmetry, and there's origin symmetry. This is an example of y-axis symmetry because to the left of the y-axis is a mirror image on the part to the right. The reason is that if the point xy is on the graph, then so is negative x comma y, and these are reflections of each other. So we're going to be testing for three different types of symmetry. So the first one is y-axis symmetry. How do we test it? We plug in negative x, and you look to see whether anything changes. So the graph is unchanged when it's reflected in the y-axis. And here's an example, a picture of what y-axis symmetry looks like. Now, if I'm going too fast, feel free to press pause and write these things down. Here's an example of x-axis symmetry. The way we test it is we look to see when you plug in a negative y, does anything change? So for y-axis symmetry, we plugged in a negative x. For x-axis symmetry, we plug in a negative y, and you look to see whether anything changes. And then for the third type, origin symmetry, we plug in a negative x and a negative y. We plug in both of them, and we look to see whether anything changes. So again, I'll repeat myself so you can make sure you write these down. For y-axis symmetry, you plug in negative x. For x-axis symmetry, you plug in negative y. For origin symmetry, you plug in both negative x and negative y. Here's another example. We want to test this equation for symmetry and then sketch the graph. So first, we want to test to see whether it's got x-axis symmetry. So for x-axis symmetry, we replaced it with negative y. And when we replace the y with a negative y, you can see up there, nothing changed. The equation's unchanged. Therefore, it does have x-axis symmetry. However, when we replace the x with a negative x, it changed. It didn't stay the same. So therefore, it's not symmetric around the y-axis. It does have x-axis, but it doesn't have y-axis. We can use that then to help us plot points and to graph this if we use the symmetry. So first, we just plot points for y is greater than 0. So I pick some y values, 0, 1, 2, 3, plug them into the equation. 0 squared is 0, 1 squared is 1, 2 squared is 4, and so on, and I get those points. And then I plot those points that I just got. Now, if I know that this graph is symmetric around the x-axis, because we just figured that out earlier, that means I can just flip it over and I have my graph. Remember, these are the only points that I plotted. I plotted that point, I plotted that one, I plotted that one, and I plotted that one. But I used the fact that it was x-axis symmetric to reflect them over the x-axis. So this point came down here, this point came down here, and this point came down here. And I was able to figure that out without having to actually plot any points. So it saved me a little bit of time. Let's do another one. We want to test for symmetry. First thing I'm going to do is I'm going to plug in a negative x and a negative y. So in this case, if I plug in a negative x and a negative y, work your way through the math here, and you'll see that nothing changed. The negative x got cubed, which made it negative x cubed. The negative x got multiplied by the negative 9, which made it a positive 9. But this is a key step. Notice that these two things, if I divide by a negative 1, I wind up getting this, and this is the original function. This is what we started with, which means the equation is unchanged, which means the graph is symmetric with respect to the origin. Sometimes you have some things that are symmetric. They have all three types of symmetry. So for example, a circle. In a circle, if I plug in a negative x, it gets squared, which makes it x squared. If I plug in a negative y, it gets squared, which makes it a y squared. So plugging in a negative x doesn't change anything. Plugging in a negative y doesn't change anything. And plugging in both of them doesn't change anything. So therefore, circles exhibit all three types of symmetry. And you can see the example here that it has all three types. Erase that. There we go. All right. Which leads us to our last little theorem. A function is even. If we want to connect these two things, how does even and odd relate to symmetry? Well, a function is even if the graph is symmetric with respect to the y-axis. And a function is odd if a graph is symmetric with respect to the origin. So that's the connection between the first thing that we did with the evens and odds and also with the symmetry. So you put a little star next to that to make sure that you have these written down. Now, before you come into class tomorrow, I'm going to give you a couple of examples here on the next page. I want you to write these down and try them to the best of your ability so that when we come in tomorrow, we can talk about them and then we can practice some more. So here's the next slide. Use algebraic tests for symmetry to check for symmetry and also for evenness and oddness of all of these types. Let me go back a minute. So write this one down. Write that one down. Write that one down. And write that one down. And write that one down. And the last one, write that one down. So there's 6 questions there for you to do, either in your notes or a piece of paper or somewhere, so that when you come in tomorrow, we'll be able to talk about these and you'll know what we're talking about. Good luck, and I'll see you tomorrow.